Hello, hope you're doing well. This is Great Circle Sailing, practice problem 4. We solve for distance and initial course. There are a couple notable things in this problem. One is that we stay in the east longitudes, which is convenient. And the second is that we cross the equator, which creates multiple negative signs in this problem. Type these numbers into your calculator carefully, and let's get going. Great Circle Distance and Initial Course Practice Problem 4. Let's take a look at Problem 4. Problem 4. And it gives us a couple coordinates. These are given in the problem. These coordinates, we call them lat 1, long 1, lat 2, long 2. We're looking at lat 1 is equal to 34:51. 34 degrees, 51 minutes north. We're going to give ourselves a little bit of room here so that we can convert these 2 degrees in a second. Longitude 1 equals 115 degrees, 01.2 minutes east. Latitude 2 is equal to 10 degrees, 16 minutes south. 10 degrees, 16 minutes south. And longitude 2 is equal to 5142.6. 51 degrees, 42.6 minutes east. In the problem, we have to have all of these in degrees only. So we are going to convert them right now. And the way you turn minutes to degrees is divide by 60. Divide these by 60, and it's going to equal 34 point, whatever this comes out to. 51 divided by 60 equals 0.85, 34.85 degrees north, and 115 point, whatever this is, which is 1.2 divided by 60 equals 0.02, 11502 degrees east. And this is going to be 10 point, this quotient, 16 divided by 60 equals 0.27, 10.27 27 degrees south. And this one's going to equal 42.6. 42.6 divided by 60. 0.71 degrees east. Now, if you look here, latitude 1 and 2, we crossed the equator. Keep that in mind. And then longitude 1 and 2, we stayed east. So both of that's going to make a difference. Let's find now D low. So we need to find D low. And D low is the difference in longitude. So D low equals longitude 1 minus longitude 2. So longitude 1 is 115.02. 115.02 degrees east. And longitude 2 is 51.71. 51.71 degrees east. Let's make sure we can just simply subtract these. We're going to look at this diagram. So 115 east. Here's 0. If we're going east, here's 100. So we're going to come back over here. We're going to be about here. 115, right? And then we end up at 51. So 51 east is over here. So we went from here, from about 120, 20, 40, 60. So we're going to be somewhere, around 60 is what we're looking for. This part, don't take it for granted. It can get kind of complicated. So we're just going to do straight subtraction to get the difference. 115.02 minus 51.71 equals 63.31. Good. Our little mental math that we played on here showed us that that's about right. So I'm going to trust that. 63.31 degrees. And is it west or east? So when we went from 115, we went 115, which is about right here, to 51, which is over here. We went west. So this is going to be named west, which is important. West. So we said D low equals 63.31 west. Now we need to find distance. We need to find distance. And we're going to use the formula cosine distance equals, it equals the cosine lat 1, cosine lat 1 times cosine lat 2 times cosine d low, plus or minus, and we'll talk about that, sine lat 1 times sine lat 2. This plus or minus, if we crossed the equator, it is minus. We did cross the equator from north to south, so it will be minus here. Now let's put in numbers. Cosine lat 1, 34.85. 34.85 times cosine lat 2, 10.27 times cosine d low, 63.31 minus, because we crossed the equator, sine lat 1, 34.85 times sine lat 2, 10.27. Now let's start laying these numbers out, punching them into the calculator. You can open the parenthesis and say cosine 34.85 close times cosine 10.27 close times cosine 63.31 close, enter. 3627. So 0.3627 minus, because we crossed the equator, this number. So we open the parenthesis and say sine 34.85 close times sine 10.27 close, enter. 0.10188. 0.10188. And so our cosine distance is going to be equal to this number. So 0.3627 minus 0.10188 equals 0.26082. 0.26082. Now we need to find the distance. We need to get rid of this cosine. We need to move it to the other side. So distance is equal to the inverse cosine of 0.26082. What's our distance equal to? And this is going to come out in degrees. Second, inverse cosine 0.26082. 74.88. 74.88 degrees. 74.88 degrees. The answer is in miles for the problem. So there's 60 miles per degree. 60 miles per 1 degree. Degrees cancel, you'll be left with miles. So distance is going to equal 74.88 times 60. 44929. 4492.9 miles. Okay. I like to go ahead and check, see if we're on the right track. There, yeah, that's very close. 4493. I would say we're on the right track, but let's find initial course. When we find initial course, we're going to have to use a distance, and our distance must be in degrees. This will be our distance in this next step. So we're going to come here and we're going to say, I'm going to say, find initial course. That's what we're doing right here. And we're going to use a certain formula. And that formula is cosine initial course equals sine lat 2 minus cosine distance times sine lat 1. And this is all divided by sine distance times cosine lat 1. All right, here, be very careful here. This sine lat 2, if you cross the equator, it's negative. We crossed the equator right here. Therefore, sine lat 2 here is negative. So we have to keep that straight. So it's going to be negative sine lat 2. Lat 2 is 10.27 minus cosine distance, which is in degrees, 74.88. 74.88 times sine lat 1, 34.85. 34.85. All of that is divided by or over sine distance, 74.88 again, 74.88 degrees times cosine lat 1, 34.85. And now we're going to start crunching these numbers. Sine 10.27, sine 10.27 equals, so this is going to be negative 0.17829 minus, we'll get this number. We can start with open parentheses, cosine 74.88 close times sine 34.85. 34.85 close equals 0.14905. 0.14905. And this is all over this one. We figure out what this number is. So open parentheses, sine 74.88 close times cosine 34.85 close equals, it's all over 0.79224. And now take it down to the next step. So we get negative minus this, right? Negative 0.17829 minus 0.14905 equals. All right, let's try that again. Negative 0.17829 minus 0.140. One more time. Negative 0.17829 minus 0.14905 equals. Let's try it again. So negative 0.17829 minus 0.14905 equals. What in the world? Let's try this. Negative 0.17829 minus 0.14905 equals. There it is. This equals negative 0.32734 over 0.79224. So we already have this number. Let's just divide it by 0.79224 equals negative 0.41318. So this is the cosine of initial course. We need this cosine to move. So we say initial course equals inverse cosine of negative 0.41318 equals second inverse cosine inverse cosine negative 0.41318. 114.4. And this is in quadrantial notation now. We'll name it 114.4. We name north or south based on lat 1. It is north here. And we name east or west based on D low. D low was west. So we're north 114.4 west. Let's graph this out and figure out degrees from north. We need to figure out degrees true. North, south, east, west. So we're north. Whoa. We're north and we're 114 degrees. So we're past 90. We're down here. No, we're not. We're west. Here we go. So we're north. Now we're west. So we go west 114. We're down here. So we need to figure out degrees from north, which is all the way from here, the other side. So what we can do is we can say 360 minus 114.4. That should give us degrees from true, right? We take 360 minus this piece and we get this piece. 360 minus 114.4 equals 245.6. 245.6. So here we're going to equal 245.6 degrees true. Let's see if our answer lines up. We get 2456 true, and we get 4492.9. Yeah, look at that. We lined them right up. 4493 and 245.6 true. And so D is the correct answer to Great Circle Distance and Initial Course Practice Problem 4.